Here our new topic is, you can read, magnetic field due to straight current carrying conductor of infinite length. Let's suppose there is this wire and it is a straight wire, has infinite length, so I can draw some dots to make it infinite. And let's suppose it has one of the point called point Q, capital Q point, and from the Q at distance A there is a point called P, where we have to find the magnetic field due to this straight current carrying conductor, has infinite length. How we can do this? One major concern is the Biot-Savart's law is valid only for the small element, and this wire has infinite length. Then how we can apply it? Simple thing is, let's suppose there is another small element we have taken, and the length of this small element you can represent it by the dl, and you can say this is a small xy. Yes, this is the xy, and it is also carrying the current, so the current would be the uniform. So I have written the current called I. Okay, and this point you can take as the, see, this is called the x, and you can take as the y. The center of this small element can be here. Say this is the point O, right? I draw one line in the direction from O to P like this. Okay, and I can take another chalk. So the angle here is the theta, and angle which is here you can take it as the phi, and here the angle is the 90 degree. First of all, we will discuss the magnetic field due to this small element which is making the angle theta, and after that we will have the resultant magnetic field due to this infinite length. So for the small element we will apply the Biot-Savart's law. Then you will write here, from Biot-Savart's law, magnetic field due to small element dB, which is equal to mu 0 4 pi, and length of the small element from the P you can write it as the R. So I have written I, the current, the length of this small element is the dl, the angle is called the theta, since then you can write the sine theta, and divided by the R square. So this is called the equation first. Let's suppose this is called the point Q, okay, and this point X is here. The gap between the center, this is called the center, the gap between Q to the center of the element dl you can written as the L. So what I told, the small element has the length dl, and from Q to the center O, right, the distance is the L. Okay, so this is called the triangle. From the triangle QOP, the angle is theta here, then sine theta. So I discussed because this is called the 90 degree, and the triangle has the angle total 180 degree. So these two angles will make the 90 degree. Then theta plus phi will equal to the 90 degree. Then theta is equal to 90 degree minus phi. So I can write the sine theta is equal to sine 90 degree minus phi, and sine 90 minus phi is the sine 90 minus theta, becomes equal to the cos theta, but there is not theta, so we will write there cos phi. So I have converted the sine theta into the cos phi form. Okay, so you can write it simultaneously because I have to erase it also. Then sine theta is equal to sine 90 minus theta, phi is equal to phi 90 minus phi is equal to cos phi. Okay, So the cos sin theta converted into cos phi. And this is the cos phi. See, if this is a cos phi, this is phi, so this becomes the perpendicular. Then from this triangle again, the cos phi, as cos phi is equal to base upon hypotenuse, so it becomes base and it becomes the hypotenuse. Then a by r, cos phi is equal to a by r. So you can take the value of the r here and you can write a by cos phi. Why I am doing this exchange? Because the small element, the magnetic field due to the small element consisting I, dl, sin theta and r square. The dl will change due to the length. The angle will also change because I have taken the angle due to the small element. The r, the distance is taken as from this small element r, but the distance can be changed. Okay, so it should they are the variable. That's why we have to convert. So I have converted the sign. I have converted the r, so only the length is left. So see here, I am changing it. Again, how you can change the length? By applying from this triangle, again you will take from triangle OPQ tan phi. If this is the phi, then tan phi is the perpendicular upon base. So the perpendicular becomes the length and the base becomes the A. So we will write length upon A, then length is equal to tan phi dot A. Yeah, A dot tan phi, so it doesn't matter. But there is the DL and I have taken the L. Then you have to take the differentiation of it. Differentiation with respect to the angle called phi. So we will take d by d phi of the L and the d by d phi tan phi dot A. Okay. So the dl by d phi you can write here, and the differentiation of the tan phi, it is equal to the sec square phi. So we will write here sec square phi dot A, and the d phi you can shift there. So the dl is equal to sec square phi d phi dot A. So these things got changed. The dl is equal to sec square phi dot d phi dot A. So you can write it together with me. I am erasing again. Okay. So the dl is equal to sec square phi. So you should carry these parameters and put it on the first equation. Then dB, it is equal to the mu 0 by 4 pi dot I will not change. The dl is sec square phi dot d phi sin theta. I have converted it into the cos theta. A is also here. Yes, A is also here, and the sin theta is cos phi and divided by the value of the r, and the value of the r becomes, what was the value of the r? I forgot. The cos phi is equal to a by r base upon hypotenuse, then I have to erase the r, then r is equal to a by cos phi. Yes, so the a square by cos square phi, and the cos square phi will go up, 1a will cancel, then dB equal to mu 0 divided by 4 pi I dot sec square phi cos square phi. A1 cancels, so you can write here that A and d phi is here. This cos phi is also there, and you know the sec square phi and the cos square phi will cancel because of the inversely. So only one thing will left, something will left. Mu 0 by 4 pi I dot cos phi dot d phi divided by the A. Yes. So this is the formula for the electric field due to this straight current carrying conductor, but it is only for the small element. And let's suppose, as I told you earlier, the length of the wire is infinite. So the angle made by from this end can be different from the phi. Say this is the phi, and so I can write here the phi 1 and this is the phi 2. But if this is the positive x-axis, so upper part becomes the positive and lower part becomes the negative. So you can write as the minus phi 2 because of the bottom line of the x-axis. So I have to find the magnetic field from this point to that point. So that's why I have to take the integration to find the resultant magnetic field. Then after this, you have to do the integration. Write it simultaneously. This is my magnetic field. The resultant magnetic field. Resultant magnetic field. Yes. Integration of the dB equal to then integration of mu 0 by 4 pi I dot cos phi d phi by a, and I told you the integration from minus pi by 2 to plus pi by 1 because this is the limit basis of the angle. No need of it. And the resultant of the dB becomes the maximum B. Mu 0 4 pi is constant, comes out. I by a is also constant, and the integration of the cos phi with respect to d phi is the minus sin phi. Sorry, this is the plus sin phi. Yes. So here sin phi, and the integration is minus pi by 2 to the plus pi by 1. Sometimes we also forward. Okay. So the B is equal to mu 0 4 pi dot I by a, and put upper limit and lower limit. Upper limit minus lower limit. Upper limit is the plus pi 1 minus sine, and this lower limit against the minus. So I will write like this: minus pi by 2 bracket, and this bracket is closed. And the minus sign will come, sin minus theta is minus sin theta, then minus minus becomes plus. So ये वाला जो minus है, you can keep it out. It becomes, and it is like B is equal to mu 0 by 4 pi dot I by a into sin phi 1 plus sin phi 2. So this is the resultant formula of magnetic field due to the straight current carrying conductor. In the next PPT, we will discuss the cases on the basis of the change in position. Sometimes this P can go here, sometimes this P can go here, sometimes the P can be here, P can be here. So what would be the resultant magnetic field? Sometimes the angle will also be same. So see this PPT. Thank you.